A very good morning, dear students. How are you all? I hope that you all are fine. So, dear students, today what we are going to start is the second part of our chapter 14, that is electric current and its effect. So, before starting the chapter, let us have a look about some good manners. Dear students, always wait your turn. Use polite words. Listen carefully to your teachers and parents. Cooperate with others. Show your appreciation and give good compliments. Now, let us start our chapter. So, in this chapter, we are going to learn about symbols for some electric circuits components. So, dear students, here is a picture in which you can see the symbols for some electric circuits and components. First is the electric cell, how is it and what is the symbol of this. Second is electric bulb. The symbol of electric bulbs, you can see it on your screen. Third is switch in on position, how the on position the switch is. It is not break up with both joint. And fourth is switch in off position. Fifth is the battery and sixth is wire. Means these are the symbols which are used in drawing the diagrams. So draw it in your fair notebook, all the symbols of the electric components. Now, what is the heating effects of electric current? So, dear students, when an electric current flows through a metal wire, here is a picture, you can see it. It offers some resistance to the flow of current, causing it to heat up. The higher the resistance, the higher the amount of heat produced, the vice versa. Wires made up of copper offer less resistance to the flow of current than most of the other metals. Thus, they produce a smaller amount of heat when used in circuits. Even thin copper wires do not offer a lot of resistance to the flow of current. On the other hand, thin wires are made up of tungsten or nichrome. It is an alloy of nickel, iron and chromium, you can say, and offer higher resistance and heat up to high temperature. Here is a diagram in which a nichrome wire warms up because of the heating effects of the electric current. Again, it is a diagram, it is shown a nichrome wire as a heating element in a toaster in which we toast the bread. Inside there is a nichrome wire which heats up very quickly. Thus, the materials used for producing heat by way of the heating effect of electric currents are called heating elements. Tungsten filaments in bulbs, here tungsten filaments in bulbs and nichrome wires in households, or you can say in industrials heating appliances, are some examples of heating elements. In a bulb, there is always a tungsten wire as a filament in a bulb. Now, the factors affecting the heating effect of electric current. Dear students, we know that the resistance offered to the flow of current in a conductor causes the heating effect. A higher resistance will produce more heat and a lower resistance will produce less heat. Thus, the factors that affect resistance also affect the heat that is produced in any circuit. Now here are the factors which affects the heating effect of a electric current. First one is the type of material. It depends on the type of the material. Second is the thickness of the wire. Third, the length of the wire. And fourth is the strength of the electric current. So, first we will learn about the type of material. Its description is that the different materials with the same thickness and length heat up to different temperatures for the same strength of the current. For example, you can say nichrome produces more heat and copper produces less heat. Second factor is the thickness of the wire. What is the description for this? It is an electric circuit's thinner wires produces more heat as compared to thicker wires for the same strength of the current, as they offer more resistance to the flow of current. For example, thin wires produces more heat and thick wires produces less heat. Third factor is the length of the wire. Now it also depends on the length of the wire. It is an electric circuit. Longer wires produces more heat as compared to shorter wires for the same strength of the current, as they offer more resistance to the flow of the current. For example, you can take longer wires produces more heat and shorter wires produces less heat. Fourth factor is the strength of the electric current. For a given conductor, whatever the conductor it is, the amount of heat produced will depend on the strength of the current passing through it. A stronger current produces more and vice versa, and the strength of the current can be changed by using cells of different voltages while keeping the other factors constant. For example, 9-watt cells produce stronger current and hence more heat, and 1.5 volt cells produce weaker current and hence have a less heat. Now, the heating effect of electric current in an incandescent bulb. Dear student, first of all, let us have a look about the word that is incandescent. It means it refers to the light that is produced by heat. In an incandescent bulb, the electric current is made to pass through a thin metal wire that is known as a filament. The filament, what is the filament? The filament is extremely thin and long, because of which it offers a high resistance to the current flow. It is coiled up. You can see in your bulb, it is coiled up so that it fits into a small space inside the bulb. Here I am showing you the picture. See here, in the middle of the bulb you can see the tungsten filament. It is a round off, so it's take a less space. The support wires keeps the filaments in its place. Oxygen is removed from the glass case using a vacuum pump, and the glass gas is filled with a mixture of inert gases such as argon and nitrogen. So if somebody asks you that tell me the which gases are filled inside the bulb, you can say argon and nitrogen. So the characteristics about the bulb, the first point is due to the heating effect of the electric current, the current passing through the filament produces a large amount of heat. The heat that is produced is so large that it makes the filament glow and emit light. Third is a mixture of argon and nitrogen is filled inside the sealed casing of the bulb. Why? Because to prevent the filament from burning. The filament continues to glow as long as the current keeps flowing through it, and bulbs with such filaments in them are known as incandescent bulbs. So here is a diagram, dear students, you can see in your screen. It is an inert gas, means argon and nitrogen are filled inside the bulb. Outer cover is known as gas bulb. Inside the middle of the bulb there is a filament made up of tungsten. It is round off because it takes a less space, and it is holded with a glass support, and the outer material, it is a electrical terminals. This is the structure of a bulb, how an bulb is made up of. So dear students, this is the topics about the electric current and its effect we have learned today. In the next part, means part 3rd, we will learn about the applications of the heating effect of electric current. What are the applications that we use to heat up any material? Till then, take care and goodbye.